So FDAP is a set of technologies that when you're building a data-intensive application, you can spend your time focused on the features that matter to your product rather than rebuilding and re-implementing standard, but still hard to implement features that are required for that type of application. My name is Andrew Lamb. I'm a staff engineer at InfluxData, and I work on InfluxDB 3.0, which we built with the FDAP stack. FDAP are the first initials for 4 different technologies. F is for flight, Arrow flight. D is for DataFusion, A is for Arrow, and P is for Parquet. And what those technologies are is they're the foundational technologies you need to build data-intensive applications, including databases. So you need a way to store the data for long term when you save it to your storage system, so that's what Parquet is used for. Then you need a way to represent the data in memory as you go and process it, right? That's what Apache Arrow is for. And when you're building these applications, you need to actually operate on it and run SQL or do other sort of analytics. That's what DataFusion provides. And then of course, most computer programs these days don't just run on your laptop, they run across the network, and so you need a way to quickly transfer the data across the network in an efficient way. And so that's what Flight provides. For InfluxDB 3.0, we wanted to add analytics capabilities in addition to the time series use cases that InfluxDB 1 and 2 were great at. In order to do that, we needed access to some of the technologies that are in the FDAP stack. So I think the FDAP stack is the culmination of 20 years of industrial and academic research that distilled down the common patterns that appeared over and over again into reusable components that can now be reused to assemble next generation systems. They got built over and over and over again, and as people built them several times, the same patterns kept emerging. So you needed file format, looks a lot like Parquet. There's a lot of versions of that, but eventually, Parquet sort of standardized that. Likewise, the in-memory representation in a lot of systems looks a lot like Arrow, and so rather than have to re-implement yet another thing that looks approximately like Arrow, Arrow standardized it. Likewise, when you send data over the network, right, you don't have to reinvent yet another way to send data over the network. And likewise, DataFusion, there's like a lot of systems that run SQL or relational plans. It's well understood how to do it, but it's still very time consuming. Yeah, an interesting thing to think about, how do you build these systems without the FDAP stack? And what you do is you raise a lot of VC money, it's like hundreds of millions of dollars, and you hire a team of 20 or 30 database specialists, which are not cheap, and then you spend 3 or 4 years building it, right? There are certain companies and corporations that can afford to do that, or if you're a big world-renowned research institution, you can probably pull that off. But if you're not one of those organizations, you basically wouldn't have access to these technologies. And so by having them in an open standard, now you're able to use and take advantage of those techniques without having to re-implement it yourself. You can always think about it as just an economic thing, well, it's making stuff cheaper, right? But I think that also, not only does it make it cheaper, it actually makes products that you never would have been able to make before affordable, right? Like instead, this would have been locked up in some, it was actually for 20 years, this type of technology is locked up in big, expensive enterprise software. Whereas now you see it starting to proliferate out through the ecosystem. And anyone who has an interesting idea can build a fast database system. And I think that just enables far more interesting products and technologies that never would have been able to be built before. So yes, it's partly a cost thing, but it's also because it lowers the cost so much, it enables much more innovation than we would have seen previously. If you're a small resource-constrained startup or company or a group of people and you're trying to build some new product, right? What you really want to do is you want to focus your time and effort on the things that makes your product unique. And the features that make your product unique are going to be particular to whatever problem you're trying to solve, versus analytic column store technology and how to represent arrays in memory and process them and run SQL. For some companies, that might be what makes them unique, but for a vast majority of them, it's just required. But then you really want to be spending your innovation tokens on features that really matter for your use case. So I think that's the core of the FDAP story, right? You mostly take advantage of what already exists, and you can spend your time and effort focused on the features that really make a difference for your product, not reinventing something that was basically well understood 20 years ago, but it's still very hard. By having the components of the FDAP stack available, you start to see more and more specialized databases proliferate, right? Built on the same sort of columnar fast execution core. But now you can see products such as vector databases are very popular right now for machine learning. Obviously you see us applying this technology to time series databases, which the traditional time series database architecture does not have columnar analytics. It's based on another type of technology called LSM trees. People are starting to apply these columnar fast execution engines to streaming systems. The traditional place this came out of was data warehousing, big distributed parallel data warehousing systems. But now that the FDAP stack exists and brought those techniques into a more reusable form, you see them being applied to different domains. I think something else that also is worth mentioning is that not only do you not have to rebuild some of this standard set of features, you also get immediate integration with the larger ecosystem. So previously what you would have had to do is you would have had your own database and you would have had your own file format, you would have had your own network protocol, and then to connect your system to all the other systems, you would have had to implement connectors, right, that let you get data out of your system, put it into some other system. And that becomes a very expensive proposition because you need a connector for every system you want to connect with. But now, because the technologies are standardized, right, when we talk flight, there's many other systems that can talk flight, right? We generate Parquet files. There's a whole ecosystem of tools that can read and write Parquet files. And so I think the fact that we're using open standards everywhere makes the ecosystem integration much easier as well. So that at the end drives even more innovation because now you can really customize your tool set for whatever works best for your problem rather than whatever happens to have a connector and lets you move data around from one format to another. And you can see the FDAP stack in action by trying InfluxDB 3.0.